Hi, good afternoon, everyone. I'm your host, Janti today. Our webinar topic is Talking Through MapReduce. This is a continuation of the Hadoop webinar series. We have Kim Tan with us today. He is the solution architect in Rackspace Asia and also the big data subject expert in the region. If you have any questions about the webinar, please type them in the chat box and we'll answer that after the session is finished. Now I pass it to Jean.
Thanks, Janti. Welcome, everybody. As Janti mentioned, the webinar topic for today is going to be around MapReduce. Now, in this webinar, we're going to be talking about exactly what MapReduce is, how it fits into the Hadoop ecosystem. We're also going to talk about some common use cases where we see MapReduce being used. And we're going to follow that up with a couple of demos, firstly showing you how to run a MapReduce program in Hadoop, and we're then going to show you some code of a basic MapReduce program to give you some context. Following that, we're going to briefly talk about some MapReduce abstractions that exist within the Hadoop ecosystem to make it easier to consume, and we're also going to talk about some alternatives to MapReduce that more recently have come about. So the first thing I want to do is, before we delve further into MapReduce, is actually take a step back and have a look at the Hadoop stack so we can put some context around the topic today, MapReduce. Now in front of us we have the basic Hadoop stack. Starting from the bottom, we have the storage component of Hadoop, which is typically HDFS and was the topic of the previous webinar. Moving on to the middle, we have Yarn. Now, we've briefly touched on Yarn in previous webinars. Yarn, of course, is the pluggable resource scheduler for Hadoop version 2, and its role is to perform scheduling of jobs and monitoring jobs across a Hadoop cluster. Now, we are going to delve a bit further into Yarn in future webinars, but instead I want to move on to the third component of the basic Hadoop stack, which is really going to be the focus of today's webinar. And that is, of course, the processing engine. Now, the processing engine is the brains behind the Hadoop operation. And today we're going to be focusing on the processing engine that started it all, and that is, of course, MapReduce. So what is MapReduce? In the context of Hadoop, MapReduce refers to a specific programming engine that allows us to create and to run MapReduce applications on Hadoop. So that begs the question, what is a MapReduce application then? Well, a MapReduce application is simply one that follows a MapReduce programming paradigm. And the MapReduce programming paradigm is actually very simple. It consists of two consecutive steps. Firstly, a map phase, where we structure or filter data, followed by a reduce phase, where we summarize that data to answer the questions that we have. Now that's very difficult to think about on its own, so let's contextualize that into an actual example. Now I'm going to use a little bit of a contrived example, but one that is considered the hello world of big data, and that is the word count example. Now, as you'd imagine, from a word count operation, you want to count the number of times a word occurs in an excerpt of text. Now, because my wife loves Hamlet, I'm going to use an excerpt from Hamlet as shown on the slide. Now, doing this by hand, I'm going to use a method that we all know, and that is the word tally method, where each time I see a word, I add a 1 or a stripe next to it, similar to the table at the bottom of the slide. So using Excel as a mechanism to record, I'm going to follow this algorithm. I'm going to read in each word, and for each word, I'm going to search for the word across the top in a column, and once I've found that word, I'm going to add a row beneath it and add a 1 to it, where that 1 represents a single occurrence of that word. Something pretty simple, really. And funnily enough, this first step is what you would call the map phase, where you map out your data, turning it from an unstructured data source to something that's more structured. And that really completes the first stage, or the map phase. The second stage, or the reduce phase, is where we actually add up the numbers. We take the output of the map phase, add up the numbers of each of the columns to get the final number which represents the word count for each word. So this example helps us recognize how simple MapReduce actually is and how we probably use it in our everyday lives without actually knowing. And many problems can be abstracted into this two-step process, and we'll talk about some of those problems later in the webinar. So given that this webinar series is about Hadoop, how does MapReduce fit into Hadoop and how does it run on Hadoop? Well, it runs actually very similar to as we've shown, except because Hadoop consists of multiple machines, our X panel is split up and distributed across those machines. And each machine will perform the MapReduce operation on the data that it holds. Now, as with the previous example, we start with the map phase. Each server reads in the words of the file it holds. It creates a key value pair for each word, with the word as the key and the integer of 1 as a value, where of course the integer represents a single occurrence of that word. Now each server creates multiple key value pairs until it's finished reading the file. Notice that we're simply structuring the data similar to as we did in our previous example. Now once the map phase is complete, we'd typically move on to the reduce phase. But in Hadoop, the machine that performed the map operation doesn't necessarily perform the reduce operation. Instead, a machine or set of machines in a cluster are pre-selected to perform the role of reducer, and this necessitates an intermediate step known as the shuffle phase. Now in the shuffle phase, we distribute data over the network so that reducers have the right data to perform the reduce operation on. And the data that the reducers receive is based on the key of the key value pair, where each reducer gets all the key value pairs for a specific set of keys. So in the example on the slide, the left machine, if it's assigned the role of reducer, will be given all the key value pairs for the keys the, or, in, by, take, end, and mind. And the machine on the right, again, if it's assigned the role of reducer, will be assigned all the key value pairs for the keys to, be, is, not, and are. Now once all the reducers have the data they need, they'll initiate the reduce job. And in this case, the reduce job will consist of counting up the number of ones of each of the key value pairs for that specific key. And the output would be another set of key value pairs with the word count for the word shown. And this really sets out what we're achieving to do. Now why MapReduce is so powerful for Hadoop and big data is that MapReduce allows each machine to run independently of other machines, and each machine only needs to process the data that's stored on it locally. And this means that Hadoop with MapReduce allows us to scale out hundreds of machines with terabytes of data to achieve massive parallelism and achieve or analyze data at big data scale. Now many of you will recognize MapReduce simply as a batch processing system, and that's exactly what MapReduce is, a highly parallelized batch processing system. And this means MapReduce is really good at performing things like basic statistics, such as performing regression analysis across data sets, which can help us find trends and correlations. It can also be used to calculate basic statistical numbers, such as averages and standard deviations. Also, MapReduce is really good at sorting and searching across datasets as well, and we can use MapReduce to perform transformations, or ETL, as we mentioned or we saw in the previous example where we structured the unstructured data. But naturally, MapReduce isn't for everything. MapReduce does rely on acyclic data flows where state isn't maintained. So if your processing relies on data from a previous state, then MapReduce possibly isn't the right model. Similarly, as a batch processing system, MapReduce isn't ideal for anything real-time, such as real-time analytics. Now, in saying this, the community has been very creative and has extended the MapReduce model to encompass many complex scenarios, such as machine learning and graph theory. So if you do need to perform work like this, there may be several frameworks out there that you can use. Now, before I want to move on, I want to mention the concept of tuples or key-value pairs. Now, in my previous example, you hopefully noticed that I was using key-value pairs throughout all my processing steps. And this is because MapReduce in Hadoop expects all data to be in the form of key-value pairs. Now, how you structure your data into key-value pairs is dependent on the data and what you're trying to achieve. So, the content of a text file, for example, could have the byte offset as the key and the line content as the value. So, a single file will consist of multiple key-value pairs, one per line. And this is interestingly enough, is the default behavior for how Hadoop and MapReduce read a file into its operations, or a text file into its operations. Now, taking a tangent away from this presentation, I want to show you a quick demo about how to run a MapReduce job in Hadoop. And I'm going to run a word count job as we did in our example. So moving over to our demo machine here. Here we have our directory, and it has a number of files in it. These files are the source code and the compiled code of our word count program. The file of interest to me here is actually the demo main.jar. Now, the demo main.jar is an archive file containing our MapReduce application, and within that archive it has all the source code and all the compiled code in order to run that MapReduce program. So I'm going to list out the contents of that archive file. Okay, and take note that there are 3 key compiled files in there, ignoring the meta-inf and the manifest file. And we'll refer to that later in the presentation. Now, starting the MapReduce job, in order to do that, we need to submit the job to Yarn, which is, of course, the resource scheduler. We specify the jar is the next word, indicating to Yarn that we are specifying a jar which contains the MapReduce application. We then specify the jar file and the name of the application we want to initiate. In this case, demo main is the application within the archive file that we want to run. We then simply provide the data file. In this case, I'm using Shakespeare's Hamlet play as the input, which I want the word count performed on, and then we specify the output location, which will show us the key value pairs for all the words, or the word count for all the words. So let that initiate. Now at this stage, Yarn is going off and doing a number of things. Yarn, the resource scheduler, will, for example, determine where the source file is in our cluster. Once it's determined that by talking to the name node, it will then initiate jobs on those clusters, on the cluster, will initiate the map job on the cluster nodes, and the map job will begin. Now, as you can see here, it's actually starting the map job now. And at this stage, it's completed the map job. It was very quick, and it's now performing the shuffle job, as we mentioned before, where it sends the data to the reducers, And now the reduce job is done, and the job is complete. Now to show you the output of that MapReduce job, let's show this to you here. And there's that process. And as you can see, we have output key value pairs in each of the words and their associated word counts. So for example, the word you appeared 495 times within the Hamlet space. Now moving back to our presentation. At this stage, I want to actually show you the source code of the MapReduce program I ran to give you some context to our next demo. Now, MapReduce programs are typically written in Java or JVM languages like Scala. They can be written in other languages, for example Python, but other languages do require additional frameworks and a little bit of creativity and hacking in order to get them working correctly. So the ideal language for MapReduce is Java. Now, a MapReduce program consists of three key components. Recall that there were three items in the jar file I showed you previously. Firstly, you have the driver class, which initiates and coordinates the program. Next, you have the mapper class that defines the map method to run on that data. And lastly, you have the reducer class, which defines the reduce method to run on the data. Now, one thing I do want to mention here is that for Hadoop, it is possible to do map-only jobs when you don't want to or don't necessarily have to perform a second reduce pass. And in this case, you would only need the driver and the mapper method. Now, moving back to the demo machine, let's have a look at that source code. So, all the .java files are our source code files. And I'm going to start by opening up the driver class, which in my case is demo-main.java. Now, demo-main.java is actually quite long for a driver class. And as mentioned, the driver class is really performing administrative tasks, for example, setting up the variables to initiate the job. And you can see that here. We set the domain.jar file for this MapReduce application, and we also set the name of the application within that archive that we want to run. Additionally here, we set the mapper class. This is where the job will find the map method, and similarly, this is where the MapReduce job will find the reduce method. There's two other things that I want to point out. Firstly, the input format class. This indicates to the job what type of format we expect to come into the job. In this case, we expect it to be a text file. And similarly, we can also set the output format, which is also a text file in this case. So our MapReduce job will expect an input of a text file and an output of a text file, since we've specified it here. The last thing to mention is the main method, which is typical of any Java program. This is where we would initiate the job from. And this is what you'd expect from a driver class. Now moving on to the mapper class. In my case, it's called mapperdemo.java. Now this is a relatively short class. As I mentioned before, it does contain a single required method in it called the map method. Now, in our previous examples, we talked about how the input to the map method will be a key value pair. And that you can see here, the input arguments are a key and a value. Now, because we are using a text file, the default behavior of MapReduce and Hadoop is to input the key and the value to be the key being a byte offset of the line, and the value being the line itself. Now, knowing this and knowing that the value represents a a line on the text file, the algorithm that we use is relatively simple for the map method, and that is to input into a string tokenizer, which outputs the line into an array of strings delimited by space. From there, we iterate through that string tokenizer. We do a little bit of intelligence and remove any alphanumeric characters on this line, and then we output from the map method another key value pair, as shown here, with the word as the key and the integer 1 as the value. And that 1, of course, represents one instance of that word. Now finally, let's move on to the reducer class. Now the reducer class, again, is very simple. Now, as mentioned in our previous example, the input of the reducer class is going to be all the key value pairs for a specific key. And you can see that here. We have a single key, and this values is all the values of that specific key is defined within an iterable object, which is really just a list of those values. And knowing that those values can only be one, as defined within our map method, we simply sum up those map methods, those ones, within this while loop here. And the sum aggregates that, giving us the total number of times that word has occurred. And the output of that reduce method is relatively straightforward, another key value pair, with the key being the word and the value being the sum itself, or the number of instances that word has occurred. So that is a quick demo, or a quick showing of the source code of a basic MapReduce program. Now, as you can see, it's not particularly simple. It is relatively complex. And even something as simple as a word count does require quite a bit of code. And as a result of this, that can actually put a lot of people off, particularly those without a development background. So to make Hadoop more accessible, many projects have been started to abstract away this complexity. Hive and Pig are probably the most well-known abstractions. Each have their own domain-specific languages. Hive specifically has a SQL-like syntax, making it easier for those with SQL knowledge to use Hadoop and query data. Pig, on the other hand, has a more procedural language, which is well-suited for those that have a scripting background, and Pig is ideal for data transformation jobs. Now, in both cases, when run, these languages ultimately compile down to MapReduce jobs, so users don't have to write complex Java programs. Now, we're going to explore both these languages in future webinars, so do please stay tuned for those. Now, the last thing I want to touch on is alternatives to MapReduce. Now, MapReduce was the first processing engine for Hadoop. It was originally created back in 2005, exactly 10 years ago. Now, as with all technology this old, it has become quite a bit outdated. And due to the rise of the internet and social media, our expectations have moved on from batch processing into things like streaming and real-time analytics, things that MapReduce isn't necessarily ideal for. And as a result of this, a number of other processing engines have been created to meet these needs. Spark, Tez, and Untitled, for example, have been created for real-time querying, and Storm and Spark streaming have been created for real-time analytics. Now, the introduction of these engines really emphasizes the importance of Hadoop and Yarn, which allow us to have one cluster but have multiple processing engines, so we can choose the right processing engine for the right job. Now, we're going to discuss both Yarn as well as other processing engines in future webinars. Now, in saying all this, it shouldn't detract away from the importance of MapReduce, which is still very heavily used within many organizations. So this brings us to a close. I do hope that this introduction to MapReduce has been useful, so you can start thinking about how you can practically use Hadoop. I would like to thank you for attending this webinar, and I do hope to see you next time in our webinar about yarn.
Hi everyone, so if you have any questions, please type into the chat box and we'll answer you accordingly.
Yeah.
Audio only answer phone, they couldn't answer it.
Oh, really? Interesting.
I don't think that she has a question. It should be automatically.
I don't know about that. We'll have to look at that. Any questions? No. Just ask question.
Okay, so we've got a question about let's know what is POC actually. So you can please answer this question.
Sure. So Arc is a new processing engine for Hadoop. It can run standalone, and it can also run on Yarn and Hadoop. It will be a topic of a future webinar, but suffice to say it is more designed for analytics of today. So we're talking about in-memory analytics, something that is not batch processing like Hadoop. So the output is something that's a lot faster and a lot more flexible than MapReduce is or can be.
So I've got another question from before. So what is the difference between the MapReduce version 1 and version 2?
MapReduce version 1 was created for the version 1 of Hadoop, where Yarn didn't exist, whereas MapReduce version 2 was a rewrite of MapReduce version 1 that could run on Yarn. Now, conceptually, they're identical in the sense that they perform the same work and they're also that compatible. Really, MapReduce version 2 simply is the version that you would use running on the new version of Hadoop, Hadoop version 2. Okay.
Okay, thanks for all questions. It is about time for us to finish the webinar this time. For any questions about the MapReduce that Jean has just talked about, please email to him at jean.ted@rackspace.com and we'll get back to you shortly. So if you want to have the PowerPoint and also the record of the webinar, please email katie@katie.chung@rackspace.com. Thank you for spending the time with us today and look forward to seeing you in the next webinar. Stay tuned.